This is the video for CSCI 447 Project 1 for Jakob Frank, Ian Hecker, Dillon Tice, and Jonah Gilbertson. So to begin, we started reading in our data sets, the CSV files, all 5 of them, into a 2D array. And then from there we appended the line ID for easier tracking throughout our code. We also added a 10% random shuffle for 10% of columns in data sets. So we can also have an original set and then an altered data set that gets sent through our code. From there, we create subsets of the data, 10 specifically, 10 for altered, 10 for unaltered, for our 10-fold cross-validation process. And then applying 10-fold CV for each of those data sets, we created a training subset and a test subset, with the training subset being 9 of the sets, and then the test subset just being 1 of the sets. And then for each of those, we applied our classifier, naive Bayes. We divided up the data by the classifiers into its respective categories, and then created the probabilities of each attribute for those classified classes. And after this, we evaluated how our algorithm did by guessing on the test subset to the trained data from naive Bayes. So we attempted classification based on test attributes, and then applied a t-test to the data. Now I'll show you it running. So here's the output for the breast cancer data set, and the first 10 outputs are going to be for the non-altered data. So it does decently well. And then for the altered data, for the 10% random shuffling, you can see the drop from about 80 to 98% accuracy to about 50 to 40. And this is just particular for breast cancer. And at the bottom we have our t-test. I'll swap the data set and show you a different one. I'll do votes. And with the top 10 being the unaltered data, and the bottom 10 being the 10% random attribute shuffled. Again with the totals at the bottom along with their t-test.